This podcast is sponsored by CDO Group, the industry leader in providing a full range of construction and project management services. CDO Group has managed thousands of projects in all 50 states. Their group of experts provides systems, processes, and procedures to make sure that your projects turn over on time and on budget every single time. With over 24 years of experience, CDO Group is the industry's leader in construction management and general contracting services. To find them, go to cdogroup.com. Hi, and welcome to the Future of Development podcast. My name's Anthony Amunategui, and I'm here to inspire people to find amazing careers in the construction development world. If you like our podcast, please make sure you hit the subscribe button down below. If you really like our podcast, make sure you hit the little bell. Hi, and welcome to the Future Development Podcast. I'm your host, Anthony Amunategui, and today I am joined by my amazing friend, Javier Glatt. Javier is a co-founder and CEO of CadMakers. He is an amazing entrepreneur. I'm excited about having him on the show. If you guys could, give me a big warm welcome for Javier. Welcome to the show. So Javier, welcome to the show. As always, I'm grateful that you got to jump on the call with me, and I'm really excited about it. When we did our pre-call and really got into this, the stuff that you're working on excites me. You know, it's really moving the industry forward dramatically, really been able to paint the picture for people, for them to be able to see job sites in a much different way and projects in a much different way than ever before. But before we get into that, I want to take a second and get to know you a little bit. What got you into this business? Where'd you start, and kind of what got you excited, and know a little bit more about you yourself.
Sure, that's great. Well, first of all, it's a tremendous honor to be on the pod with you, and it's great to connect with you, and very like-minded kind of worldview, I think, in terms of the impact construction can have, and technology and construction, and how it touches the lives of so many. It's such a big industry. So how did I get started? So I have a weird meandering path. I was an average student athlete. I played football, baseball, basketball kind of thing. And into university, I was focused on football and baseball at the time. And I ended up playing professionally football up here in Canada for a number of years. And so I was a bit of a late bloomer. I spent most of my 20s in tights running around doing dog piles every weekend and getting beat up for a living. So after a while, the headshots start to accumulate, and I started wondering what I was going to do, grow up and get a real job and figure out what I was going to do with my life. So when I was around 30 or so, I decided to go back to school, and I had a real passion for real estate, construction, this kind of work, just because of just through osmosis and meeting people in the football world that were kind of in the construction and real estate development industry. So I interned for a year in a real estate development firm, and while I was doing just before my MBA, and then I in that year, which I basically did for free, which was an amazing experience, I learned a lot. I remember being in a trailer with a site superintendent on a very large project, and we're over the drawings. It's 2011, 2012, I can't remember what year it was, and he's explaining to us how these floating stair detail is not constructable, for many technical reasons, while we're trying to construct it. so it's the outside of the trailer, there's a mobile crane trying to install this thing, and I thought to myself, I don't know enough yet to really make a conclusion here, but seems like something we should try to flush out beforehand. Of course, people do, and I'm not trying to speak down. It's challenging to connect design and engineering and construction, installation, fabrication, installation. It's a challenging thing. But overall, that was kind of where the light bulb went off and said, hey, if you can build things digitally first, you're going to probably have a better chance of success from the site perspective and work backwards. Or what's the problem we're trying to solve and work backwards? So I interned, worked at another place in big capital projects, understood what things cost, understood some of the problems we were trying to solve. And then my co-founder, really smart engineer, he came up through kind of the technical side, worked for a couple places, but he worked for a famous architect in Los Angeles called Frank Gehry for a period of time, and was doing kind of fancy high-end stuff there. And when we met in school, I kind of had an idea of the problem we needed to solve. He had an idea of how to solve it in a unique way. And that was it. We decided to leave our jobs and give it a shot, and got a storage locker and did the whole bootstrap thing, and just kind of snowballed from there, trying to get a little bit better each day and work on cool projects. And that's where we are today. So the love of construction for me came from seeing others in my kind of sphere working in the construction world, being on site for that first year was just magical. I loved going to site every time. I just loved it, walking the site, seeing that often the smartest, most talented people in the room were the construction superintendents and the foremans that are on site figuring things out. And I just thought to myself, if we could find a way to work closely with that, take that knowledge and that experience and help with digitize that if we could, it would be like a lethal weapon. You got all this practical site knowledge with this digital technology. We're pretty good at computers. How do we connect the two, right? So that's kind of how it all started for us.
Well, that's awesome. I've said it all along. Since we've been able to get the BIM modeling has really changed and really changing the way the future of the construction is happening so much faster than ever before. We did a rollout program a couple years ago with McDonald's. It was 6,500 store rollout program, and one of the hardest things was understanding to go out and get scopes, to develop the scopes, right? So sending people to job sites, you'd have to send somewhere around 7 to 11 different teams of people to a job site just to get the scope. And that would be from the architectural surveyor to general contractors, subcontractors, operations teams, all of the different vendors and coordinators that needed to go by and look at a job site just to get it scoped. And we realized something. We said, all right, if we can take a job site and bring it to them, it would dramatically change the experience, right? I mean, just think about the thousands and thousands and thousands of dollars of tickets, airlines, days. To do a site meeting with a general contractor, all the subs, and a project manager, you may have a dozen people on site, and you figure at $1,000 a day per person. Just that alone, plus, that's your airline tickets and your hotel stays, just to be able to come in to look at a store for what may be a 2-hour meeting. And what we were able to do was say, let's stop doing that. We took the Matterport cameras and we were able to go out and digitally look at the building, photograph the building, and create these fly-throughs and take the job site and bring it to everybody. And it was the first time we'd ever done a massive rollout program. And it dramatically changed the timing of the job site. So as that happened, what you're working on is really helping that future vision, right? So that's getting everybody, information about the current job site. Now, as we start to look forward, the number one problem we have on job sites is getting our superintendents and our project managers to be able to paint the picture for the subcontractor that's going to show up. Or even more important, forget them. How about for the operations team to know what's happening? And your products of your software are able to take the job site and take those 2D plans and make them 3D, where people can see through them, kind of what they're going to look like when they're built.
Yeah, I mean, it's like a couple of things that jump out at me when you're talking. Maybe that's why I've been drawn to construction. It's quite a team sport, and I grew up playing football. It's one of the ultimate team sports. I played all the sports, but football is a unique one in that you got 70 teammates. There's not too many sports where you have such a big team, and you have many different specialist roles. You have some roles that are the star, some roles that are the lineman, never touch the ball, but they're actually very, very critical to the success of the team. And there's a lot of parallels to draw into construction, and no different than if people are football fans here, how the game has evolved over time to more spread offenses and throwing the ball all over the place, and having smaller players that were more nimble, being able to play with the big players. Construction is going through a similar transformation, which is saying, do we have to, in the past, stick build on site, figure it out on site with some smart people who've done it before, was the lowest risk way to build a project. It may take longer, it may cost more, a bit more. But as people start to trust technology in their everyday lives, it seems like there's this transition happening where people are starting to, like when we first started 2014, there was a lot of lack of trust in digital technologies, right? In contract documents, 2D drawings, this is what drives specs, this is what drives stuff, right? And people just had to think in 3D and think in 4D and understand these things. And I've seen a big shift in 6-7 years to people trusting, and lower tech folks, right? Trusting the way to actually de-risk a project is not to do it on site, stick build. It's actually to build it first, digitally, verify it digitally, integrate supply chain if you can digitally. You mentioned operations is a great use case, making sure people that are going to operate in the building or in the finished product can access certain hatches and switches and things like this, and how do you validate that, right? So no, it's a fantastic transition. It's great to see that. I know you got, and you're building unique projects in that you have a mixture of engineer to order and some, built in situ type of interfaces, which is the most complicated. So you have some, base building stuff that's got its own constraints, and then you have fryers, pre-made equipment coming that needs venting, and they need specialized kind of requirements for access. So this is where it gets really tricky. We worked on a pool early in our life of this company, and that was really an eye opener for me, right? It's like, wow, you open you can order a sedimentation tank. Did we think about how to bring it in? At what point should you bring this giant tank for the pool in? After you formed all the walls, poured the concrete, started installing doors, it no longer fits. Like the thinking, it's a different type of level of coordination that's required, and doing things digitally can really reduce that risk. So now I think we've crossed the chasm that, similar to aerospace, automotive, these types of things, where they de-risk projects and product development with digital and like digital fabrication and building things going directly to machines, so file to factory, this type of stuff. It's now becoming more and more pervasive in the construction industry, which is fantastic.
No, for sure, that's the ultimate in being able to coordinate all the different players. I find us in the business that trust thing happens. You just get this. The one of the biggest problems I see is that we operate under this what we call the lying program. Right? Somewhere someone's got to lie to each other to get a job. Right. So for me to get a job, I got to go bid it. I can do it for $10. You can do it for $9. No, I can do it for $8. Somewhere along the way, someone's got to give you a little bit of BS that they're going to do the job. And then somewhere they're going to go figure out how to do it for that price. Right. Because somewhere, the right price was the price I bid it for originally, at 10. Now someone's like, all right, I'm going to cut some margins, but because I want it, it's a McDonald's. It's a great brand to have under my flag. And then someone's going to come in and go, nope, I'm going to do it for $8 because I really want this. And now I've got to figure it out. Now, in that may cause some great efficiencies, right? There may be some great opportunity at $8 for me to figure out how to be smarter, better at this. And hopefully they create the same product with quality, but figure out smarter ways of doing it. Now, the problem is that I have to start over again on the next project. The same team I had for the last project, I don't get on this project, right? For 20 years now, we've been building hotels. And 20 years ago, we would take a whole hotel room and we would take the entire room and we put it in a bundle and we slide in the front window, the front wall before we put the wall on. And we'd have the bed, the carpet, the nightstand, the sink, the bathroom sink and the fixtures and all the tile and all the stuff that goes in there. And we would save ourselves hundreds and hundreds of trips up and down the stairs. Right? We're talking going back 20 plus years. Right? I mean, we thought we were genius back then. We're like, oh my God, we're genius. And by Moore's law, today, we should be building hotels in a week or in a weekend, right? I mean, we should double every couple of years. And by today, we'd be really rolling. But that's not true. Today, we start over as if every brand that we work with starts anew. And we're lucky if we can carve 4 or 5 weeks off of a job because we're just a little smarter. And the brands that we work with love that we go faster, but the other contractors they work with can't go faster. The vendors they work with don't commit to the timing. So inevitably, we will be rolling on a project. Our team, we turn over more stores where the operations team and vendors aren't ready, and we don't care. I tell everybody, turn the store over, build it out, get it ready, let us sit there. And if it takes them, another 2 weeks to get the equipment out there, still, what happens is we want to be ahead of the game every single time, right? It's the behavior that we are. We stay in that fit condition. That project speed is the game. And without having those tools that you're developing, where people can see it, subs show up here. I'll give you a great example. When I tell you mobilization? Right? What do you take mobilization as?
From a construction term, typically setting up the site. First, putting fencing, putting laydown areas, figuring out where you're going to, set up your site. That's what I know it as.
So on my calendar, I have on my schedule, I say mobilization. At the end of day one, what do you expect to have happen at the end of day one?
Typically safety, so fencing, gate, maybe, I don't know, a trailer set up, potentially, any maybe a tank for if there's any hazmat or anything. I don't know. I actually don't know after one day how far it would be, but something like that. Yeah.
All right. So one of the biggest problems we have is that word is used on schedules every single day. And to you, it means that. To the subcontractor, it means, hey, I'm going to get all my gear over to the job site, but we're not going to do anything. I'll get my backhoe and my forms and my scaffolding. I'll get it over the job site, but we're not going to do anything with it. And I mean, to another group, it may mean digging footings and foundations and getting started in the morning. So the way that we communicate leaves this nebulous space. With tools like yours, where we can start to paint the picture and go, today, here's what we're doing. We're going to dig this trench. I'm going to need, 3 operators for backhoe equipment. I need them to bring these 3 operators in. They're going to dig the dirt out and be able to pile it over here. Because if you pile it on this side, the guys that are doing the underground plumbing won't be able to start working on the underground plumbing on the inside of the building if I pile it on the inside. If I pile it on the outside of the building, maybe my guys that come in with scaffolding or the work that's happening next won't be able to operate. So knowing how we operate on a job site affects all the other people that are out there, right? So I think as Javier, as you and I start to be able to paint the picture a little bit more, right? Operations can see what they're getting. And then we can start to communicate to the subcontractors what we're looking for you to do. That's where I felt like your software did such a great job of being able to say, hey, here's what we want to get done. And on day one, I want to be able to have this going. And we're going to work on this section. And you can start to highlight that section and bring the tools and techniques to get that to happen.
Yeah, absolutely. Early on in our company, we were fortunate to work on this project. And one thing you said really resonated with me around, basically, for better or for worse, is you're only as fast as your weakest link, in construction, meaning if you have, especially when you start getting into, say, concrete, cast in place concrete, high rises, it's pretty optimized. There's only concrete only cures as fast as the chemistry will allow you to go. So it really comes down to cycle times of trades. And we worked on this project. It was at the time a very innovative kind of it's a mass timber, heavy timber, cross laminated timber project. Blue lam columns and timbers and mass timber slabs, and then prefabricated panel envelope. So we did a lot of work helping with digital delivery on this, to break to fabrication, lots of integration, lots of simulation of different processes, work scopes, as you mentioned in the trailer, working through essentially a rehearsal of the build. And then what happened, a bunch of prefabrication happened, a bunch of automated means happened, yet the steel stud was still done kind of stick build on site. And which is great learning for us. And, it's hard to know if there's a better way to do these things. It's not a perfect science. But one learning I took from that is, if we were to do this again, we would actually look at the longest time, operational times, things like stick buildings, steel stud walls for internal demising walls, and saying, okay, well, what can we do to automate that process? Because we could do 2, 3, 4, 2.5 floors a week in theory, plumbing risers, primary structure and facade. But then, the whole thing grinds down because you're waiting for the framer. And so as a team, when you're basically a general contractor, construction manager, superintendent, you're basically just an orchestrator at the orchestra. They'll just say you. And then, if you realize you get to an operation that's going to just throw everyone off, that's that type of foresight to look around the corners is really useful. And that's where a lot of the technology we're trying to build is helpful for that. It's, there's no perfect silver bullet, but as much as you can practice and simulate and try, think and communicate better, collaborate with many people better, get buy-in from them, you're going to have a better time on the construction site when it goes to go live, right? And from what I learned in my past life, 85 to 90% sometimes of the costs on these jobs are hard, meaning spending it in construction, the soft cost, the design, the engineering, and the total cost. And if you look at operations and maintenance, it's even less. It's, most of the cost goes into building it. Let's work on that side, right? Let's really focus on that side, because that's where you're spending all your money.
You can see very quickly where your point about the inefficiencies of scheduling, right? If I show up with a crew of 5 people and I can't work, it just happened. I was down in Atlanta, and as I'm flying in, my flight's delayed because of a rainstorm. I get into Atlanta and I have a job site meeting with one of our guys that's, one of our clients is getting ready to turn over. Landscapers are going to be in the morning finishing up some landscaping. And I get to the job site and there are 5 or 7 guys that are all standing around doing nothing. And I'm like, well, why are these guys standing around? And you could see that the job site was flooded, right? And the landscaper had showed up to do landscaping. And the night before, there was a torrential storm. And the problem we had was that job site now the landscaper sent out his entire crew to that job site, and there was nothing going on. They couldn't work. It's red clay, it's mud. They get the backhoes out there. They just would have dug grooves into the ground. It never would have worked. And instead of someone saying, hey, maybe we should call these people off, right? Our business doesn't do that. Guys don't think that way. They figured, oh, I'm scheduled. I got to go down there. It might have made sense for that guy to send his crew to the shop, or send his crew somewhere else where he might be more effective, where he's not in the middle of a red clay mud field and they're not going to be able to operate. Now, that owner of that business is paying, and I said to our super, I said, hey, super, send these guys back to their shop, right? Do the owner of that company a favor today and help him, have his crew go do something else today rather than stand around here, and being ineffective. And as we start to look at the technologies that are coming, I did a podcast earlier today with an AI expert that's really working on integrating. Right now there are multiple different platforms that everybody's working on. You're working on telling the story, the digital story of what it's going to look like in the future, right? And your platform is really creating that visualization of a 2D drawing and showing what it looks like in the future. There's other groups that are working on mapping software, other groups that are working on weather software. There are other groups that are working on, Autodesk is taking Revit and it's taking the set of plans and breaking them down into little tiny nuances, right? To be able to look at a wall and look at the drywall mud, the paint, the screws that hold the drywall in, the drywall pieces, the metal studs, the screw that hold the metal stud together, the track, the bottom track and the top track. And instead of just being a line on a drawing, now these are individual components. And I can now order from those components. I can now have deliveries based on the ordering from those components. I can place them on a job site where I need them. I can do predictive guessing based on schedule and past performance of employees as to how much I need on a job site, so I'm not clogging up a job site. And I can also take in consideration what's happening with the weather, right? If I'm looking at my schedule and I realize, hey, my weather forecast shows that it's going to rain for the next 3 days, and I'm scheduled to do outside siding, I may not want to have it all delivered today because it looks like it's going to rain for the next 3 days. And being able to make those adjustments and get a lot more streamlined, I think ultimately makes each of the companies way more effective and makes it much better cost profile for them.
Absolutely, and that should be the goal ultimately, is driving efficient or taking out inefficiencies of the business, utilization rates, getting those up, using technology to solve real world problems. There's a lot of, unfortunately, especially as construction has evolved, there has been some technology in search of a problem to solve, right? So, you got this new tech, let's go find a problem to solve in construction, right? Let's do that. But we're very passionate around work going the other way around. Like, well, what's the problem that we're trying to solve, and let's build technology to solve this. And one thing it's become very evident to us is this kind of concept of this digital simulation and how that can drive things. And for us, it was really affected by being fortunate enough to work with Tesla for many years. So one of our first big customers on our services side was the Tesla Model 3 team, and we were pretty heavily involved there. And what I learned from this is a couple of really foundational things that's driving our key products in Builder.io at this point. One was that this idea of, can you build a digital twin of something, right? And what does the factory look like? Well, factories started going into this digital twin concept quite some time ago. Whether it's connecting the physical world and digital world, not yet, but it was lots of automated machinery coming into a building, process simulation driving, inputs and outputs of actual physical machines and humans working together in a factory, right? And so this is a closed environment. This car is getting built very in an automated way. So that was a really interesting learning, like how the factory has evolved. They have things like PLCs, which is like a brain essentially of a factory that says, okay, if I build this car up and it's got 80, 90 stations, there's a sensors and there's a process which it goes through to build the product. Moves from one station to the other, triggers something, goes to the next. So that kind of was interesting to me. And the other side of it was this kind of idea that the car would just get better every, the over-the-air update, right? And you go to sleep at night, you wake up the next day because it's connected to the internet, it just got better, right? You update the car, it goes faster, it drives longer, the battery technology is better. It's like, this is baffling. And, for construction, when we set out to solve the problem of kind of construction simulation, we looked at the future and worked backwards. So we said, okay, Anthony, actually the jobs that you do, this is a great opportunity because, we're starting to see like backhoes and different types of graders and some types of small cranes become either autonomous or semi-autonomous, meaning someone's out, not actually inside the machine running it, right? They're running it from outside the machine, or like Dusty Robotics are doing a wall layout robot, which is using computer vision or seam tracking and actually working on its own, based on, so driven from a CAD model or something else. But this idea is happening, right? So this, as this construction site evolves into prefabrication, semi-autonomous and autonomous machines, in 10 years from now, 15 years from now, it's going to be like the factory I saw at Tesla. You got all these robots working with humans in one cell, and it things moving across pneumatic systems and all these different types of systems. Well, the construction site, which has been mostly manual for many years, some automated machines, hoists and things like that, but humans are running them. And there's lots of humans on site doing the work. As that changes, it kind of occurred to us that, well, wait a second, you're going to need like a brain of the construction site. This is going to need to come. And that brain is going to need to be in the cloud, meaning you are going to need to be able to connect through sensors, IoT, this type of things, to the physical world. So it's going to have to be web-based or like internet enabled. And then what I learned in the manufacturing world is you never start anything without a model. So you've modeled it first, you've flushed it all out, you got bill of materials, got all this stuff. That's what drove the productivity increases in the manufacturing world. So long-term, Anthony, I believe in 15 years, that's where construction will be, especially on larger, more complicated sites. So you have this need for a model-based, web-enabled, internet-enabled engine that can act like a brain. And the first thing that all these autonomous companies do is they simulate. So like, let's say you're doing self-driving, they train deep neural nets on synthetic data, and they simulate in almost like a gaming environment first, so that you get trained on that and you go into the physical world and things look similar and the physical world can adapt. So what we're trying to do is step one of that, which is build a simulation engine. It has to be 100% web-based and it has to be accessible for everyone. Meaning, Anthony, I don't want you to have 2 or 3 ninjas on your company that does everything for everyone. Can your superintendents, your project managers, your project coordinators, maybe low-techy folks run this engine because they're the ones making the decision. So how do we make it accessible? How do you allow someone to digitally simulate your project first? And how can you drive a better outcome, when you go to build a project? That's step 1. Step 2, which is step maybe 5, is much later, is like, once you've simulated this, you flush it all out digitally, how can you push the outputs of that and connect it to the physical world? And actually the crane is being moved based on a schedule, based on inputs and outputs that you've already simulated. And you've done your best. It's not going to be perfect, but you've done your best to validate that all those picks are going to be working and the timings are working. How long is it from pick to place? How many resources are at the place? And installing parts. You can simulate this and get good tack times or times to do this. So that's the engine we're starting to build now.
We've learned that through automation, that the speed by which we can make adjustments is dramatically faster. Now, we've seen it in space flight. We've seen it been able to in engine controls. We've seen it with the automated vehicles that are out there. I love my Tesla. I love Tesla. I love it. I love my Tesla. I love driving it. I love when I go down there and I see I've got an update on the horizon coming at me. I can't wait to see what the next thing is. And when they added my car can fart, I thought that was. I thought
my kids like that one.
Yeah, I thought when it could enter and exit the highway, I thought, all right, great. And I look forward to a day when I never have to adjust it. I never have to drive, right? I could sit back and do what I need to do while in the vehicle. And, it's able to make hundreds of thousands of control decisions way faster than I ever could. And I think that's the part that is going to really revolutionize the speed by which you're doing it. You predict 15 years out there. I don't see that being that long. I see that what's happening, the people I'm talking to today are in the next 3 to 5 years, a dramatic change in the equipment that's going to operate job sites. I just did a podcast with a guy that's printing a home every 40 hours, right? They're 3D printing these homes. They're printing them at $4,700 a piece. The change, in the materials that they're using are revolutionary. They're still working on catching up with the code compliancy. And I think that's probably the thing that's slowing it down the most is, local adaptation to code compliancy. And, again, we are slowing it down. It's able to make those adjustments so much faster, micro sensitivity to each and every one of the adjustments. And it's like different than you and I, where I can make a couple of them, but I get worn out after a few. I might be able to make a couple dozen or, 100 or 150 of them. But at some point, I'm at a max capacity to make continuous adjustments just because of fatigue. And as you look at these systems that are being operated, you can see where, construction could happen 24 hours a day, 7 days a week. It can make adjustments based on product availability, manpower availability, weather conditions, dry times, product specifications, all the things that you and I are continuously ebb and tiding for. But by the time we make these decisions, it's having multiple effects continuously, where they're able to make those decisions just like your software. It's able to see them and make those adjustments to schedules before impacts, which I think ultimately will make it that much faster. It's an awesome conversation. We're seeing that happen. Javier, I think that the work that you and your crew are doing is revolutionary. It really does paint the picture for the entire team to operate on one platform and see it better. And as that gets smarter, you can see how that it can break down that scope. Right now it's painting pictures of what the product looks like. But as it starts to take the 3D AutoCAD drawing into Revit and find the parts and pieces of it, and then start to do the scoping of each of the development of the project, from the schedule and manpower requirements, you can see very quickly how we can make adjustments right over to the field of, all right, do I need 5 plumbers on site this week or 7? And based on, hey, we're going to have a weather front come through. We're not going to use the guys that are out digging the dirt, putting the plumbing in. We can use the guys that are in the building. Great. We'll be able to make micro adjustments and take those crews and put them in other places that will be more effective. So what's coming really excites me, right? And you guys are on that leading tip of development of software. And Javier, I love what we're doing with this conversation. I love where we're going with it. As you continue to develop it, I would like to see more and more of your input. So I'd love to have you on the show again and continue to talk about your latest and greatest developments of the product.
That's great. No, it's we're on the right track, I think. And a lot of what you just said, there's a couple things that hit me. One is just to kind of wrap up from my perspective, I'll pontificate a little bit in the future, but right now we're in our product development roadmap, we're focused on pre-construction because, having a good plan pays back, 10x in the construction site. Often I'm sure you don't get enough time to do proper planning because the owner doesn't give you enough time, but that's why we got to make things fast and easy to use. But right now we're focusing on the pre-construction side and simulation side and temporary resources. But what you just hit on was really, really powerful. And this kind of idea of dynamic rebalancing. So we didn't get that shipment. What's the next highest best use of time for a certain resource because of that, right? And so the engine we're trying to build is like an operating system. So if you think about it, if you're building an 8-story building, level 1 goes before level 2, columns go before beams go before panels and slabs, etc. So there's a logic. And then, depending on what that element is, you mentioned parts and pieces coming out of the model. Everything's model driven. Once you know what that part is, you know what types of available resources are there to install that piece. Is it a spider crane? Is it a human? If it's less than X pounds, it's a human. If it's greater than a pound, it's a spider crane. If it's greater than that, it's a tower crane, so on and so forth. And when you start adding those up, you can run different simulations. Say, oh, I thought I was getting this package of materials and it's been delayed by a week. What's the next best use of the resources we have coming on time? Okay, well, let's move them over to the north side of the site and work on these other operations, right? So simulating that and doing rebalancing in the construction phase is a big focus for us in the future. And it's really, I think, going to drive a lot of things. And the last thing I wanted to say before the 3D printing of the house, that was actually our company. We were focused on 3D printing at the beginning. We pivoted to the digital side, but it's really fascinating, the material science side of things. I think it's just so much biomimicry and these types of approaches. So it's 3D printing the house, but then it's using the different types of lattice structures of the actual material to make it stronger relative to its weight, which will allow you to even go cheaper and faster on site. And I think material science has just dramatically transformed aerospace and other industries with composite technology, et cetera. And we haven't even scraped the surface of this in the construction industry. So it's really fun, and that we're not in that world, but I sit back with my popcorn ready, hoping to see the DuPonts of the world and the folks of the world innovating on the material science side so that we can go even faster on site and have better, more sustainable solutions that are easier to install and have a longer life cycle, all that kind of good stuff. So I'm glad you brought those things up, because those are things that are really exciting as well.
Well, Javier, as we sit back and we eat some popcorn, watch this stuff evolve. Look, it's always very interesting to get you. If people want to get a hold of you, what's the best place for them to reach out and catch you?
Yeah, so you can just, I'm pretty active on LinkedIn. So you can just message me there. Our product is cmbuilder.io. Go check out cmbuilder.io. That's probably the best way. My email is javier@cadmakers.com. Email me if you want, but it's always great to collaborate, and I really appreciate this opportunity to connect with you and talk about two things obviously we're both passionate about.
Javier, I'm so grateful, brother, to have you on the podcast. Look forward to us doing this again. And thanks for coming on board.
Fantastic. Thanks, Anthony. Take care.
Thanks for joining us. My name is Anthony Amunategui, always looking for people to bring insight into the industry, finding ways to inspire people to have amazing careers in the development world. If you liked our podcast, make sure you hit the subscribe button down below. If you really liked our podcast, make sure you hit the little bell. Thanks again for listening. Please share it with your friends.